remind me what empirical probability is.
Is it actually doing it?
Yes, it's when you actually do an experiment. So, with empirical probability, if we're going to explain how we use empirical probability to determine whether a die is not fair or loaded, it's also called. So, we're going to actually do the experiment, and if it's a not fair die, what should happen?
What is a not fair die?
Meaning, what should happen when you roll a die is you should get approximately, the same number of ones, same number of twos, same number of threes. I mean, they should all come up about the same amount of times. You should be just as likely to get a 1 as you are a 6. So, if it was not fair, what would show up? Or what could show up?
One of the numbers.
Any of the numbers, that's right. So you'd show up with a bunch of 1s or a bunch of 2s, and see what's inside a die are little weights, and it's supposed to be centered so that when you roll a die, it is just as likely to land on whatever side. But sometimes, people that are skilled at cheating could switch out dice and get them, use their own dice, and it'll land on a specific number they wanted to more often. So depending on, like the game of craps is a dice rolling game. And so if you ever, I know you can't right now, or if you ever watch it on TV, the people who are running it switch out the dice like quite often. They use brand new dice out of a new case and everything, so that they're basically proving that the house, the people who are running the gambling, they are not cheating. So to answer this question, to use empirical probability to determine whether a die is loaded, you would just do an actual experiment, continue rolling the die, and show that a specific number shows up more than the rest of them, a lot more than the rest of them, statistically more. Okay, we talked about this one. I didn't even put 10C on there, so you don't have to worry about that. If we end up having questions on this, we'll go over those. Okay, this is a problem from that book I was talking about yesterday. Number 28 says in the U.S., more male babies were born than female babies. In 2000, that number is 2,076,969. And 1,981,845. We want to find the empirical probability of an individual being born male. So the probability, of course, you don't have to write down that problem. You can if you want to, but you need. Okay. So which one of those numbers would I put on top? Yeah, this one. Because since we're looking for the event of males, we would put the one that has males, number of males. So it's 2,076,969. On bottom, what would you put? No. Now, if I had the probability of females, that would go on top. On bottom is always what?
The total.
The total. So this is where you add these two up. course, if you wanted to, you could use a calculator. This is a really big number. I can see they're not both even because they don't end in even numbers, so I'm just going to leave it like that. Okay, so on top is the number of males because that's what we were looking for, and on bottom should be the total, always, all of them added up. These are two different problems. In biology, you talked about Mendel and his little four-way box that we use to figure out dominant and recessive genes. So we're going to figure out probably both of these. So, out of this list, how many were tall?
787.
Yeah, 787 tall plants. And then short ones were 277. So, probability of tall, what should go on top?
The number of tall plants.
Tall plants. And Angela, what goes on bottom?
The tall plants and short plants added together.
Yep, the total. So 787 plus 277. I got 1064. Now, if you had your calculator and you wanted to see if this would reduce, if you weren't sure, you could type this in just as you see it, 787 divided by 1064, and then hit the math button and enter twice. And it'll reduce it if it's reducible, which it's not. So for part B, probability of a short plant, you put the short number on top, and the total would still be on bottom. And that does not reduce either. Did a lot of drawing on this one, sorry. So Jim Handy finds an irregularly shaped 5-sided rock, and he labels each side and tosses the rock 100 times. The results of his tosses are shown in the table. Find the empirical probability that the rock will land on side 4 if tossed again. So we're trying to find the probability of 4. The number of times it lands on 4 goes on top. And of course the total number of times it's thrown will go on bottom. So how many times did it land on 4? 13. And how many times did he toss the rock?
100 times.
100. Yeah, so right here. And if you didn't know, you could add up all these numbers here, and they should add up to equal 100. And that also does not reduce. So we're just doing more empirical probability problems. And that is it. I knew today was short. So I'm going to upload pictures of this so that you can do these problems.